Past a small lobby, through a plain set of double doors,
Welcome to one of our chip labs.
there's a simple room filled with a couple hundred machines, blinking lights, a handful of engineers in lab coats, and a bunch of postage stamp-sized chips being put through rigorous testing.
Our goal is to be able to find bugs, manufacturing issues, design issues. We want to find them so that we can fix them and address them before we ship our chips into our systems.
Apple has enjoyed soaring valuation for years thanks to its forward-facing consumer products: MacBook, iPhone, Apple Watch, AirPods. But under the hood, it's also designing its own custom silicon that powers them all.
Mac transition is a proud moment. When we started scaling our chips to iPad and watches, proud moment. Building chips for the AirPods that you couldn't ship otherwise, proud moment.
Apple first debuted its own semiconductors in iPhones in 2010. As of June this year, all new Mac computers are powered by Apple's own silicon too, ending the company's 15-plus years of reliance on Intel.
I think one of the most, if not the most profound change at Apple, certainly in our products over the last 20 years, is how we now do so many of those technologies in-house.
But Apple isn't immune to industry risks. All its most advanced silicon is manufactured by one player, Taiwan Semiconductor Manufacturing Company. Smartphones are just recovering from a deep sales slump, and competitors like Microsoft are making big leaps in generative AI.
It's doable on Apple's last year chip, even more capable on this year chip with M3, but the software has got to catch up with that. So the developers take advantage and write, again, tomorrow's AI software on Apple Silicon.
CNBC went to the company's California headquarters, where we were the first journalists allowed to film inside an Apple chip lab, and got a rare chance to talk with the head of Silicon about how it broke into the incredibly expensive, complex business of processors, kicking off a trend of non-chip companies like Amazon, Google, Microsoft, and Tesla now rushing to do the same. Apple launched the first iPhone in June 2007 with a 90-nanometer processor inside made by Samsung. In 2008, Johnny Srouji came on board after stints at IBM and Intel.
I came to Apple with the purpose of building our own silicon for the iPhone. It was a very small team at the time, about 40 to 50 engineers, and since then we have grown the team immensely.
A month after Srouji joined, Apple bought a 150-person chip startup PA Semiconductor for $278 million.
They're going to start doing their own chips. That was the immediate takeaway when they bought PA Semi. Just, I think, knowing the culture of Apple, their inherent design focus to control as much of the stack.
Indeed, 2 years later, Apple launched its first custom chip, the A4, in the original iPad and the iPhone 4.
And we built what we call the unified memory architecture that is scalable across products. We built an architecture that you start with the iPhone, but then we scaled it to the iPad, and then to the watch, and eventually to the Mac.
Now, Apple's Silicon team has scaled to thousands of engineers, working across chip labs in places like Israel, Germany, Austria, the UK, Japan, and the US, in Austin, San Diego, and Silicon Valley, where we were the first journalists to ever film inside one.
On either side of me, there's about 70 machines testing chips, and these are the M3 series that are going in the new MacBooks, as well as the A series chips that end up in iPhone 15s. And these machines in particular are testing them for extreme temperatures, high heat, low temperatures, things like that.
Our board holders, we've kind of color-coded them. And what that does is that makes it easier for our engineers and the technicians to just be able to spot, oh, I'm looking for an M3 validation board.
The primary type of chips Apple is developing here are known as systems on a chip, or SoCs.
It is the silicon and all of the blocks that go onto that silicon. So there's CPU, there's GPU, there's DSP, there's accelerators, and in Apple's case, there's also an NPU that runs the neural engines.
Apple's first SoC was the A series, which has advanced from the A4 in 2010 to the A17 Pro announced in September. It's the central processor in iPhones, as well as some iPads, Apple TVs, and HomePod. Its other major SoC is the M series, now powering all new Macs and more advanced iPads. First released in 2020, it's now up to the M3 Max. The S series is a smaller System in Package, or SIP, for Apple Watch, first launched in 2015. H and W are even smaller chips used in AirPods. U chips allow communication between Apple devices. And the newest chip, the R1, is for Apple's Vision Pro headset, processing input and streaming images to the display within 12 milliseconds.
We get to design the chips ahead of time, working with our partners from John's team and software and OS. to exactly and precisely build chips that are going to be targeted for those products and only for those products.
The H2 inside the second-gen AirPods Pro, for instance, enables better noise cancellation. Inside the new Series 9 Apple Watch, the S9 enables unusual capabilities like double tap. On the iPhone side, the A11 Bionic in 2017 was a major milestone because it had the first Apple Neural Engine, a dedicated part of the SoC for performing AI tasks totally on device.
That was when we first started looking at, wow, how do we bring this advanced intelligence into things like our camera pipeline? So things in iOS 17 today, like being able to lift the subject from a photo.
Now leading marketing for the iPhone, Kyan Drance has been with Apple for more than 15 years. She says the latest A17 Pro is another major leap forward, enabling big changes to features like computational photography.
You can take 7 different shots, all from the same location. This is a macro shot. And then you've got the ultra-wide lens at 13 millimeters. With iPhone 15 Pro Max, you can go all the way up to 5x optical zoom.
The A17 Pro's new GPU architecture also enables advanced rendering for gaming on the iPhone 15 Pro.
It was actually the biggest redesign in GPU architecture in Apple Silicon history. So we have hardware accelerated ray tracing for the first time, and we have mesh shading acceleration, which allows game developers to create some really stunning visual effects.
Now, for the first time, some big games are coming out with iPhone native versions. Ubisoft's Assassin's Creed Mirage, The Division Resurgence, and Capcom's Resident Evil 4. Apple says the A17 Pro is the first 3nm chip to ship at high volume.
The reason we use 3 nanometer is it gives us the ability to pack more transistors in a given dimension that is important for the product and much better power efficiency. We're leading, even though we're not a chip company, we are leading the industry for a reason.
Apple's leap to 3nm continued with the M3 chips for Macs announced in October. These are the main chips CNBC saw being tested in Cupertino.
We've got one of those M3s in this thermal station. We have a socket, and then the chip is in there. And then the thermal actuator is kind of applying heat or cold directly on the package of the SoC.
The M3 line enables new features like 22-hour battery life and, like the A17 Pro, boosted graphics performance.
It's early days. We have a lot of work to do, but I think there's so many Macs now. Pretty much all Macs are capable of running AAA titles, which is not what it was like 5 years ago.
Now Apple's hardware chief, John Turnus, has been with the company for 22 years.
When I started, the way we tended to make products is we were using technologies from other companies, and we were effectively building the product around that. We had we've always had an incredible design team, and we made these beautiful products, but they were constrained by what was available.
In a major shift for the semi industry, Apple turned away from using Intel's PC processors in 2020, switching to its own M1 chip inside the MacBook Air and other Macs.
It was almost like the laws of physics had changed. Like all of a sudden, we could build a MacBook Air that's incredibly thin and light, has no fan, 18 hours of battery life, and outperformed the MacBook Pro that we had just been shipping. And we just launched a MacBook Pro with M3 Max that is 11 times faster than the fastest Intel MacBook Pro we were making, and we were shipping that just 2 years ago.
Intel processors are based on x86 architecture, the traditional choice for PC makers because a lot of software is developed for it. But Apple bases its processors on rival ARM architecture, known for using less power, helping laptop batteries last longer. The M1 was a proving point for ARM-based processors in high-end PCs, with others like Qualcomm, AMD, and NVIDIA now developing ARM-based PC processors too. In September, Apple extended its deal with ARM through at least 2040. Back when its first custom chip came out 13 years ago, Apple was the only major non-chip company trying to make it in the cutthroat, cost-prohibitive semiconductor market.
Apple's sort of the trailblazer. They sort of showed that if you do this, you can have a stab at differentiating your products, and certainly more players have gone down that route.
In the last few years, Amazon, Google, Microsoft, and Tesla are among the other behemoths that can afford to try their hand at custom chips.
I think what everybody was looking for was, does this really bring them a true sustainable advantage, right? Because that's really the question. It's an expensive endeavor.
Designing your own chips is incredibly expensive. Is this CapEx sustainable?
We have thousands of engineers, but if you look at the portfolio of chips we do, very lean, actually. So very efficient. Again, because we focus on the quality of engineers we hire, we focus how we run our teams, and because we're not really selling chips outside, We focus on the product, and that gives us freedom to optimize. And the scalable architecture lets us reuse pieces between different products.
But Apple isn't yet making every piece of silicon in its devices. Modems, for instance, are one big component Apple has yet to conquer on its own.
And their processors have been remarkably good. Where they've struggled is on the modem side, is on the radio side in the phones. Modems are hard, and they've been struggling with it.
Apple uses Qualcomm for its modems, but that relationship is strained following a 2-year legal battle over IP. A settlement brought an end to all legal action in 2019, and then Apple bought the majority of Intel's 5G modem business for $1 billion in a move to develop its own cellular modem. That hasn't happened yet, and in September, Apple signed on with Qualcomm to supply its modems through at least 2026.
Qualcomm still makes the best modems in the world. And honestly, until Apple can do as good of a job, I have a hard time seeing them fully jump to that.
Talk to me about what's going on in modems and the recent announcement to extend the deal with Qualcomm and why that decision was made.
We have a strong team internally working on enabling technologies that would elevate our products. But I can't really give you much and comment on future technologies and products for obvious reasons. But we care about cellular, and we have teams enabling that.
I would argue personally that the longer it takes Apple to move away, the more likely it is that they will never do it, because it's a moving target and it's hard. That being said, Apple's got a very good semiconductor business in general. I wouldn't put anything past them.
Apple is reportedly working on its own Wi-Fi and Bluetooth chip, but for now, it's got a fresh multi-billion-dollar deal with Broadcom for wireless components, and it relies on outsiders like Samsung and Micron for memory.
Does Apple have aspirations to be in charge of every single part of the chip, including, let's say, memory?
Our aspiration is the product. We want to build the best products on the planet. As a technology team, which also includes the chips in this case, if there is a technology that we can buy off the shelf and that delivers to our objective for the product, we'll do it. Because I want to focus the team on what really, really matters.
Regardless of how much of its silicon needs Apple manages to design in-house, it'll still need to manufacture its chips externally at massive fabrication plants owned by foundry companies like TSMC.
It's like anybody else. They need leading edge semiconductors. There's mostly one place you get those right now, which is Taiwan.
This leaves Apple, like all advanced chip companies, vulnerable amid China's mounting threats of invading Taiwan.
I think there is obviously a lot of tension around what would plan B be if that happened. There isn't another good option. You would hope that Samsung is also competitive and Intel wants to be there, but again, we're not right now. It's really all at TSMC.
That's why Apple has committed to becoming the largest customer at TSMC's coming fab in Arizona.
We always want to have a diversified supply, Asia, Europe, and the US, which is why I think TSMC building fabs in Arizona is great, and other founders are doing the same. Right? There are other founders, Samsung and Intel, and others, building in the US, so I think that's great.
But another concern is the shortage of skilled chip labor in the US, where advanced fabs haven't been built for decades. TSMC says its Arizona fab is now delayed to 2025 because of a lack of skilled workers. Some have also asked if a fierce talent war for good chip engineers has led to a slowdown in Apple's release of new chips.
There's been questions about why the iPhone line might have had last year's processor in the lower end and then the newest processor. Some of that also I think just might have to do with capacity at TSMC.
Generations are taking longer because they are getting harder and harder. And the ability to pack more and get power efficiency is also different than 10 years ago. But given again, I think this is actually one of the advantages that Apple has, because we're not a chip company. So I don't need to worry about where do I sell my chips.
In 2019, Apple's chip architect Gerard Williams left suddenly to lead a data center chip startup called Nuvia, bringing some Apple engineers with him. Apple sued Williams over IP concerns, then dropped the case this year. Qualcomm bought Nuvia in 2021 in a move to compete in ARM-based PC processors like Apple's.
I can't really discuss legal matters, but we truly care about IP protection. When certain people leave for certain reasons, that's their choice, that's fine. And again, as I mentioned, we have thousands of engineers and we have a deep bench of talent.
Another challenge facing the whole industry is that smartphone sales are just rebounding from their lowest levels in years.
The smartphones have been horrible, right? And part of the issue is what is smartphone? They all look like this. It's like some black rectangle of glass. So the industry is playing with things, they're playing with things like foldables. I think people right now are hoping that maybe AI will drive an upgrade.
Thanks to hype around large language models like ChatGPT, the need for silicon has skyrocketed in recent months, primarily on the graphics processor side, where companies like NVIDIA and AMD dominate. But non-chip companies are also getting in on the trend. Google has designed a tensor processing unit for AI since 2016. Amazon Web Services has had its own AI chips for the data center since 2018. And now Microsoft has a new AI chip, released in November.
What does Apple have in the works when it comes to AI chips?
In A11 Bionic, which we shipped in 2017, and given typically we start a chip many years ahead, it tells you how long we started. We built our machine learning engine. We call it the ANE, Apple Neural Engine. And that's one compute element. We have embedded machine learning accelerators in our CPU. We have our highly optimized GPU for machine learning.
Apple's neural engines power what it calls on-device machine learning features like Face ID and Animojis.
We continue to push and we continue to see more and more applications, more features in our operating system that take advantage of this, and yeah, it's a really exciting time.
In July, Apple reportedly built its own large language model called Ajax and a chatbot called Apple GPT. It's also acquired more than 24 AI companies since 2015.
Critics have been surprised that Apple appears to be falling behind when it comes to AI. How do you respond?
I don't believe we are.
Not too worried.
Not too worried. And actually we have an advantage. Again, go back to we own the silicon, the hardware, the software, the machine learning, all in one team. We're going to optimize for that.
All the things we've seen about generative AI start to come to these devices at a platform level, right? Apple hasn't been there yet. Apple had an opportunity to really get on that from day one. But, I think everyone expects it's coming, in the coming year.
In the meantime, Apple is getting ready to ship its entirely new R1 line of chips for the Vision Pro early next year, which means thousands of engineers like D'Souza will be running them through rigorous testing behind closed doors at Apple's chip labs all over the world.
It's just a source of great pride to say, okay, we worked on this and, here's the end product that we're actually using. It's fascinating.